Hi, this short video clip serves as a short introduction to the Starwader's portable solar system model, which we will in future refer to as the PSSM. It will show how it can be assembled within minutes and again disassembled also within minutes. It can then be packed away and stored until it is next needed. My name is Neville Young and I developed the model and have used it over the last 10 years. The portable solar system is used to show the position of the planets at any point in time, and then to clearly explain why we see the planets where we do see them. In addition, the model can be used for a number of other things. It can be used to show the morning and the evening stars. It can show where the moon orbits. It can show how the moon is positioned during a solar or a lunar eclipse. The model can be used to help understand why the sun is said to be in a certain constellation. This model can also be used to explain more complex phenomena like the transits of an inner planet across the surface of the sun, such as we have just seen with Venus moving across the surface of the sun in the last few months. The model can also be used to explain why we see Jupiter's moons from edge on. Another feature of the model is it can explain the phenomena of retrograde motion, where a planet appears to move backwards against the background of the stars. And then, of course, the model will also be able to show us and explain the phenomena that we are so well aware of, which is summer and winter here on Earth. This model packs away into a very small convenient package, and it's easy to pack away. So I think what we should do now is get right ahead and I'll show you how to build the model, and then we can get on to explaining how we demonstrate some of these phenomena.
Assembly of the portable solar system model starts with the base. This is the base. The legs simply pop into it. And then the upright, and then the stays are hooked into the hole on the end of the leg. The stays can then be adjusted so that the upright does stand up straight and that they are just taut enough so that the upright does not wobble, so that it is stable.
That's how it would stand, and we're now going to fit in the upper upright. Right, the final part of the structure is the upper upright, which simply slides into the lower upright. We now fit the neck into the base and the uprights, and the neck simply fits into the top and the upper upright. What we could do is, if we wanted to orientate the model horizontally, we could use the straight neck, which will then orientate the model horizontally. The next part of the model that we would fit would be the axis and its arms.
A major improvement to the portable solar system model is the hub. The hub now includes an image of the sun, and in the background it shows the directions in which the various constellations are, as well as the hour angles. It also includes the positions of the southern winter solstice, the southern summer solstice, and the positions of perihelion and aphelion of the Earth in its path around the Sun. These will be explained in another video and in the manual.
It is a bit easier to put the arms into the axis before the axis fits onto the model. So we'll take the arms. They have a long end after a slit and a short end after the slit. So we'll use the long end, and that just slides into the axis. Once the arms are in place, it is simply a matter of sliding the axis over the neck. Right, now we get to the nitty-gritty of the model, and we're going to now fit the hoops, which represent the orbits. These are the assemblage of hoops, and an important thing to remember is one of the hoops is reasonably tightly wound, and if you remove the fastener of the hoops, it can tend to jump up. So this is Mars's hoop, hoop number 4. So we'll first remove Mars's hoop, and we will then open it, and we will continue assembling the model using the other rings. Be aware when opening the hoops that they do spring open, so hold them away from your body and allow them to spring open. We now begin to populate the arms of the model with the hoops, which serve as the orbits for the planets. When putting the hoop in position, just ensure that the joint will not be over one of the slits which hold the hoop in place. So right, we push the hoop into one of the slits. If it's a little bit tight, just bend the model slightly backwards and the hoop slides very easily into the slit. Push back, pop it in. Push back, pop it in. Right, now that we have the hoops in place to form the orbits of the planets, we can begin to put the planets in position. Of course, we would first of all put the Sun in position, and the Sun fits very easily over the end of the axis. However, we do first of all fit a rotation direction indicator onto the axis so that we are reminded all the time of the direction in which the planets are turning. From the southern hemisphere perspective, they are orbiting in a clockwise direction. The first planet that we will put in position is Mercury. Mercury is made up of a little hemisphere with two little slits in either side, and it's an easy, simple case of opening the slit and placing it over the corresponding hoop. The general principle with fitting all the planets is that they are made of little balls, and the little balls do have a slit in the one side, and by squeezing on either side of the slit, the little mouth pops open. This makes it easy then to slip the planet over the corresponding orbital hoop. We'll come back to Earth in a moment. In the meantime, we'll continue with Mars. Mars is a red hemisphere, and once again we split it open and fit it over the hoop. Jupiter is the largest of the planets. Here it's easy to see the slit, and we push the slit open and slide it over the orbital hoop. Do note that these planets are just being put into random positions at the moment for this demonstration. One would normally put them in positions of where they actually are at the time, as determined by having a look at the Heavens Above website or whatever other resource you have. Saturn is made using the little orange ball, which again fits over the hoop. And then of course Saturn has rings which make it easily identifiable. So we take the little ring disc and fit it over the Saturn ball. We move on to the outer two planets, and here we have Uranus, which is hoop number 7. And right at the outskirts of the solar system we have Neptune. Then we get to Earth. And Earth is similar to the others in that it is a ball with a slit in it. The difference is that Earth does have the continents and the seas pasted onto it, so it is quite easy to recognize. And again, press the ball slightly on either side of the slits and slide it over the hoop. The planets are now in position, and this setup can then be used to explain how the different planets are seen relative to the Earth. We'll get to that in another video.